meeting. So let's combine them and get the important business stuff right online. So next thing we'll do, we'll have Treasurer's report. Howard Clearfield come up and talk this. A quick membership snapshot from Will Beckett. And then we're going to have, hopefully this is going to work, we're going to have Chris Neff calling from New Jersey, and that's going to be real tricky because he's got a long marketing report to present. And I would like him to be heard as well as I am. I got the PA system here now and everything works well. Then we'll take a break. That'll be the end of the meeting, end of the official general members meeting. And we're going to have a special speaker who came from New Mexico here. His name is Victor Woke, and he'll be in shortly. He's sitting in the back, raising his hand. There he is. And he's going to talk about wheel motors. He gave us the special input on December. We'll put it in December current events. Remember that issue. Talking about wheel motors, he's been working on these things for quite a while, and it's pretty revolutionary what he's done. Full pun intended. Okay, let's get going here. Year in review. 2014 was a real interesting year. I have not put a lot of pictures on this slide because most everybody knows what these EVs look like. We're talking about BMW's offerings, the i3 and the Uzi i8, the Kia Soul EV, Mercedes-Benz E-Class. These are all pure battery electrics. The Porsche Panamera is a hybrid, really expensive, nice looking second rendition. I guess they've renamed it the SE hybrid. Volkswagen has released their e-Golf, and in Europe the e-Up. And we had an e-Golf here last month where we actually got to look at it, take some test drives. It was actually an employer down here to drive it. It's pretty cool. VIA Motors has gotten some dispensation from the feds to get a $7,500 credit for their conversions. They have trucks, vans, and SUVs. Those are plug-in hybrid electrics with extended range. They want to call them. And then Nissan in Japan has released the NV200. We can still forevermore later off in the future talk about fuel cells. Honda made a big announcement. They're working on the next rendition. Toyota has actually named their product the Mirai, and we'll see how well that sells. I'm all about battery electrics, not very much into any form of gasoline usage. Fuel cells, that's a joke. Okay, we all know the bottom line here. A new entry in all-wheel drive Tesla P85D, awesome car. Now go down to your local dealer and test drive it. They're just incredible. Okay, on slide 2, the year in review. We had lots of infrastructure expansion, and J-plugs are rolling out. We're finally seeing the combined charging solution from SAE rolling out on things like the Chevy Spark. The 2015 has it. I called up a dealer and said, hey, can I retrofit my 14? No, buy a new car. Thank you. So anyways, lots of superchargers. They really popped their coverage in the final 2 quarters of 2014. Tesla superchargers are lots of locations. There are nearly 400 of them worldwide. And let's see if my electronics works here. Yeah, good. Okay, so hyperlink from that page. We're now on one of the later slides in the deck, way at the end. There are 393 as of yesterday afternoon with 2,146 ports available all around the U.S. And that's the snapshot as of today. And here's what their plan is for 2015 on the second charge. This is planned ended the 2015 charging locations. You can see 2 major laterals across the U.S. 10 years ago, I stood here and said, my dream is to be able to drive from my house to Yosemite and charge up in Yosemite and back. Well, that's reality. That's really nice, and I know a lot of people have done it. And I said, I further envision, going from San Diego to Vancouver in an EV, up the West Coast, and maybe from Miami up to Portland. Well, here, look at a mere 10 years later, they got all that. Plus the laterals in between the coasts. I mean, nobody lives in Wyoming except for Chile. So, and here's another map from ChargePoint. I'm sorry I screwed up their logo. It's minus ChargePoint plus, not plus ChargePoint. So on this last slide here, this is where they have locations. I just read an editorial a couple weeks ago in Risk.org. Some lady is saying, oh, there's 9,000 charging locations in the U.S. She's making big fanfare out of Midwest, Kansas City, and Minnesota, and all these other places. Having big infrastructure build-up projects. First off, your numbers are wrong because your data. If you went to the government, AFB, or something like that. And there are probably 50,000 or more. We're just talking the top 2 or 3 ADSE vendors who've got deployed charging stations all over. And this is charge points location. There's lots of other maps like this, so let's go back to the presentation. Okay, back on page 2 or 3, year in review. There's improved driver access to charging locations when you're away from home. And just go to plugshare.com, carstations.com. There's lots of maps you can use on your iPhones, your Androids, to be able to find things wherever you are. If you're lost in connection, you really don't want to charge, you need to find something. It's usually quite easy to do. And then if worst comes to worst, you can always whip out a $5 bill and approach a private party. I've done that, it works. They're very happy to take the $5 for 20 minutes of charge. Okay, surprisingly, this bottom bullet here on the slide number, whatever here, 4, sorry. The majority of EV drivers still charge at home using 120 volts. The majority of Nissan drivers, surprisingly, the majority of Tesla drivers charge at 120 volts. Not everybody has a high-powered wall connector in the garage, or, you know, forget about getting 3-phase power at home unless you get a shop in that. You need that stuff. 120 works. So range anxiety, it's probably okay. On slide 3 of 3, year in review, we had a really successful National Drive Electric Week, and that's where our EA is getting together with Sierra Club and Plug America, and had a lot of response nationwide in 152 cities. And let's use this hyperlink again and go to the map for that. This is right off the National Drive Electric Week page. This was formerly called Plug-in Day, but we couldn't decide on what day, and people could say, well, I'm doing mine on Monday. And for various reasons, we said, okay, we'll give you 2 weekends and a week in between. So that's where it is for 2015. And this will be our 5th anniversary. We really want to make it big. And, there were amazingly really good displays in Atlanta, all over the place. I mean, I'm glad they came out very good about that. But once again, look at my own unpopulated. I should stop picking this. Okay. Back to the deck. Okay, 90,000 people got their vehicles, got involved in vehicles. Lots of test drives. I think we had 5,500 according to the bottom goal here, over twice last year. And that's the name of the game. As my local friend here says, we need to get butts and seats. That seems to have caught on. Thanks for pointing. Okay, more details on the bottom link there. Let's go to the next page. A quick summary of Current Events magazine. We had another full year of 12 issues. Unlike what we used to do long ago, we have quarterly issues or every other month. Looks like e-copy is really popular. More and more of our members are doing e-copy, and that's where you get a notification. So I will, as a membership person. The new issue is available. You can go to the website, read it on the website, or download it. The e-copy is color. The hard copy, the printed copy, is black and white because it's so expensive to print color. So we still have our promotion going on. Anybody who's just recently bought an EV, sign up for our bonus. We need a special promotion code, which is EAA 2015 BEV, or it's EAA 2015 PHEV if you have something with both.
Which is available to new members only.
Okay, yeah, exactly. New members only. So anyways, and if you signed up within the last month, maybe we can make some arrangements. Anyways, web reader option is surprisingly not super popular. We have something called Bluetooth, and where you can actually click your mouse in the upper right-hand corner, draw it across like you're flipping a page, and that actually works. But not many people are using it. We're watching the statistics. Free access to the old copies. We go back to 2001, and you can see some of the rough spots that we had. Some of the stuff's pretty amazing. Our page count's been steady. We're typically around 44 pages, and then we're always looking for contributed material. We've had some real interesting things, but it takes a lot of chasing to get people to edit their stuff and give us feedback in a timely manner, so we're planning way in advance. Okay. Okay, now what I'd like to do, and let's see. This is going to be real tricky. We want to need to have a forum. We need to establish a forum here. This phone trip is going to be, I'm not sure if this is going to be. Okay, normally what we have is yearly elections in mea culpa. We didn't have any elections this year because, first off, last year we had an incredibly low turnout. It was less than 10%. And there was low interest. I couldn't get anybody who was interested to run for the board. So I'm thinking again, the board is pretty fat. There are 11 people, and we need that many. So it turns out Howard is end of term. He's stepping down as our treasurer. Anthony Barna is also, his term is up. He has resigned officially, because you know. And Carolyn Heyman's term is also up. She served 3 years, and these are all East Coast people except for Howard. So majority of the board is outside. Well, it turns out we're half and half right now. And what I wanted to do is downsize the board. Our bylaws allow us to have up to 11, but we don't have to have it. And given the amount of interest in serving on the board, and it's work, it's almost another job. We basically are going to make an appointment here. Well, this whole thing is going to fall apart because our appointee, we got one submission candidate statement. We put it into the February edition of Current Events magazine on page 3 with a kind of statement of strategy, what we want to do up on top. His name is Gint Federis. He just called me about half an hour ago. He's got a flat tire out on Interstate 580. He's calling AAA. I don't think he's going to make it. So, in the way this is working with the telephone connections here, chalk it up to lack of technical savvy. How much that hurts. I wanted to have a meeting here, but I don't think we're going to have critical mass. So, I think the lines are open. Can I do a quick roll call? Do we have Hari Khan on the line? Anybody say anything? I'm not hearing anybody. This is difficult. Tell you what, let's table this instead of listing. We'll have to conduct our special meeting at another time. What we wanted to do was appoint Gint as a new treasurer, and if we need to have elections, we can do that at a later time. As it works out this year, we're running out of time. We have one out of time, and we can always put that off. Okay, so.
We have 5 board members.
That's not a quorum. Okay, I got 2 texts here. One from Carl. Carl is telling me we can hear you. Very good. And Chris is telling me people are speaking on the 800 number, but you can't hear them. So what are we doing wrong there?
Yeah, my guess is you have to turn on the response.
The call is active.
I thought that was the default. But
It is not. Wow. I don't want to end the other.
no, it's a star something, right?
Okay, hang on a second. Let me
Star
unmute everybody.
62 or
Unmute everybody.
pound 6?
You said
It says it when you go in.
Count
it's like
5.
*6 for mute.
That's really. That figured, I'm sorry.
Aren't you black technology?
Ah,
Okay,
voices.
we can hear voices. Great. Do I hear the voice of Hari Khan?
Yes, you do. Hi, Ron.
Great, thank you. Do I hear the voice of Carolyn Heyman? Great, thank you. Okay, who else we got out there? And Carl Vogel.
Yes, I'm here.
Great, thank you. Larry Tuttle. I do not hear Larry Tuttle. Okay. Who else is out there? I'm going to sneak ahead to the. Here's all our people. We have Guy in house. We have Mark Geller in house. Larry Tuttle's not there. Terry Hirsch is here. Chris Neff, do I hear you? No, I do not. That's bad. Okay. And
Yes,
Gene,
Ron is on the line, Rich.
excuse me.
Hey, Ron, this is Chris.
Chris is there. Great.
Ron, can you hear me now?
Anthony, are you there too?
Yes,
Okay, cool.
yes, Anthony Barnes too.
Okay, great. Let's go back. Let's hold this election here. Okay. We've done a quick roll call. We did it out of order. Want to call this special meeting of the EAA Board of Directors to order. We've just done our roll call. We have established quorum. Okay, it's February 28th, the record. Time is 10:22. We'll call this special meeting to order. Want to make a motion to appoint Gint Fideris as treasurer of the EAA to take the place of Anthony Barna, who's resigned. Do I hear a second?
Second.
Okay, Mark Geller has seconded that.
Okay.
And let's see, I got a test. Excuse me a second. Yes, I do. Ari is here too. Great. Okay, we know that. Okay, thank you. Okay, we've got a motion. It's been seconded. Is there any discussion about this? Has anybody read Gint Fideris' candidate statement? It was on the Current Events magazine that we published about 2 weeks ago, page 3, February edition. Eminently qualified. Unfortunately, he can't make it here. I wish he would. He told me to call me once AAA picks him up. He's driving electric, by the way. Okay, if there's no discussion, let's hold the vote. All in favor? Aye?
Aye.
Anybody online? Any more online? Okay, I saw 5 hands here, including myself. I think we have it by acclamation. Is anybody in dissent? Anybody against this? Crickets. Good. Okay. Let the record show that we have appointed Gint Fideris in absentia as treasurer to serve starting today after Howard is done. Hands over to me. Okay, I think we're done. Do I hear a motion to adjourn this special meeting that we had?
I move to adjourn.
Okay.
Second.
Second. Thank you. Guy Hall has made the motion, and Howard is seconded. We are done. We have a new appointed treasurer. And here's the slide number 8. Board of directors as we stand. Guy is right in front of me here. Larry is absent. He's in Ann Arbor, Michigan. He's probably out shoveling snow.
Yeah, right.
No, we're probably by the heater because it's apparently really cold. Easy for me to say. Okay, Terry Hirschman is here. I think Scott's got legs home for him. All right, Con is in New York City. Chris Neff is in New Jersey. Tiny is in the middle of nowhere. Bill is in Long Island. Again is in Lafayette, and I'm right here in Silicon. So, and Mark Dillon, who's in San Francisco. Thank you. Sorry.
Remember how to do the mute?
Yeah, let's go mute lines.
Give everyone else.
We have
Give everyone
one
else
non-coastal person on the board. Anyone else?
Not who person?
Coastal.
Oh, not coastal.
I don't accept the minutes.
Well, we're gonna be here.
Okay, I think I muted everybody. That should sound the rustling sounds. Okay, still on page 8 here. Will Beckett is continuing to do our membership duties. We've automated a lot of things.
Just let you know.
Okay. So anyways, I want to give a big thank you to the hardworking directors. Howard Clearfield, he's really taken up the slack as we converted from a rebate system of revenue sharing to a revenue sharing system. We initiated that about 3 years ago, and he's been working through a lot of that. So thank you, Howard, for your efforts. Let's give him a quick hand. Similarly, Anthony is with Con Ed. He recently resigned from Con Ed. Thank him for his service, and also Carolyn Heyman. She's moved between Florida and Washington, D.C., and she's back in D.C. working there. So thanks for everybody's service there. Let's move ahead. Howard, are you ready to get up? Okay. I'll give you the clicker.
A quick lesson.
And it could be less.
Advance it.
Okay.
It's pretty straightforward.
Great. And there's a laser?
Yep. It's the top one.
All right, thanks a lot, Ron. So 2014 financial, I am going to be brief this year. Ron asked me to keep it under 10 minutes, so that's the goal. Anyway, so basically what we decided to do a few years ago was to split accounting up to just account for the general funds, the chapters, and the special funds. and we're maintaining that. Basic sort of highlights there for the general fund. Negative cash flow. In other words, we spent $28,300 more than we took in 2014. We'll get to some of the particulars of that in a minute. We still have 2 certificates of deposits that we maintain as reserves, which is $21,000. We've cashed in 2 of those to pay for some of the efforts that you'll hear about later in the meeting. We consolidated our original 26 special funds into 5, which are listed here. The total assets of the organization, including what's due to the chapters, what they have available to spend, the special funds and the general fund, as you can see there, $115,000, and that was down $28,000 from the same period in 2013. All of our taxes and informational returns and things have been filed and paid. We are a charitable organization, a 501c3. According to the IRS, that status is all current and valid. So in 2014, the consolidated donations to the special funds, the chapters, and the general fund, just under $42,000, which was down $4,000 from 2013. The major reason from that was that we sunsetted Driving Electric, which was a kind of a marketing effort to connect potential would-be EV owners with current EV drivers. Went dark in 2014, didn't collect any new money. They had collected, I think, $50,000 in the first year, close to it. So in any case, I listed the 4 top money-raising chapters. These are the type U chapters of which the EAA maintains. The board actually maintains the funds in a bank account and acts as those chapters' bankers. So actually, real kudos here, I think, to these 4 chapters, in particular, the Golden Gate EDA and Greater Sacramento EDA both raised over $10,000 in 2014, mostly to support their Driving Electric or their National Drive Electric Week activities. And as you can see, that those 4 chapters represent over 75% of the money that was raised this year by the Type U chapters. So in any case, good job on some of their really active chapters. So a little bit down from last year, 24 chapters versus 26 that actually were active and spent funds last year, spending $32,000. The board actually allocated, there were 8 new chapters created between 2012 and 2013. The board took a vote to allocate $250 of seed money to each of those chapters, with a proviso that they spend it for National Drive Electric Week last year. Only 2 of those chapters spent the money. So it does, as Ron was, kind of picks up on the theme that Ron was saying, hard for people to actually get out and do something that's making an impact. So what we do, when Ron mentioned that we went to the revenue sharing system, so for chapters that don't spend their allotment of revenue sharing funds in a given year, we take it back and we redistribute it to the chapters. So some chapters lose as much as a few $100s if they're inactive over the course of the year. So here are the details behind what I was saying before. If you notice, so over here, this is where we spent a lot of our money. Our largest share of funds was spent on current events, the magazine. We also decided to increase our liability for special events last year in insurance. So we were almost 100% over budget on that. Our membership expenses and payment transaction fees continue to go up. And somewhere in here, oh yeah, right there. We also decided to embark on a marketing effort to raise awareness of EAA and to raise membership up. Our expected income last year was $72,000 or for 2014. So we we made a conscious decision to run over, in other words, run negative cash flow for the year by a little over $10,000. And as I mentioned on the previous page, that ended up being $28,000 because of a very large shortfall in income So our total, didn't put the total income here, did I? In any case, our total income was down substantially from 2013 revenue. The donations, actually chapter donations did go up. Apparel sales were through the roof. We printed up several thousand t-shirts during the course of the year, and they went like hotcakes. So mostly for Drive Electric Week. Decreases in membership. This dropped by over $10,000, and in ad revenues as well. So we were basically about 30,000, close to 30,000 overspent for the year, but really it doesn't mean that it's not like we're falling off the edge of the cliff. We have plenty of money in reserve to cover all that. So here are the cash flows and balance sheets behind that. So for here's really, yeah, 57,000. We would have been expecting 72,000. So we were about 15,000 under on revenue. Expenses, so about 28,000 for the general fund that we were over. As it turns out, the chapters raised 39,000, spending was 32, so there's a $7,000 gain. Special funds, only $400 in donations, $7,500 in spending, including a $5,000 grant to Adopted Charter. Thanks, Ron. That went for finishing the project in Point Reyes, right? So, and then so the consolidated total was we dropped about 28,400, and if you add up our total assets at the end of 2013 and at the end of 2014, it's about 28,000 difference, which is what the state likes to see when we file our taxes. And so this is a proposed budget for 2015. I think this is the last slide, right? One more. So it looks pretty much like what we spent in 2014. Current events down slightly because the number of copies, as Ron mentioned, that we're actually printing is going down over time. We've got $10,000 allocated for marketing, 9,000 in membership expenses. Those are the major items, and I anticipate that we'll be making some more T-shirts and other apparel items this year that'll go up for sale. So we'll have some costs associated there. So this budget will need to be approved by the board of directors at their next meeting. So it could be changed. That's why I say proposed up here. We're expecting income here of about $57,000. So if this budget were to be adopted, it would be a drop of $31,000, which still is we can tolerate probably one more year of a drop like that, and still be okay. So it needs to be revised and approved the next month, and then there'll be action required on the redistribution of the unspent 2014 revenue sharing. Okay, so what is it looking like for chapters in 2015? So the total available should be $54,000, and that is as of the end of the year. So there has been chapter activity already, in particular Sacramento and Golden Gate have been active already, so they're so that does impact that number. But that was as of the end of last year. Again, just reminding that any revenue funds and revenue sharing funds that were allocated during the year have to be spent in that year. Otherwise, they're subject to being taken away and redistributed back to the other chapters. Just a reminder that any donations that are earmarked for a particular chapter stay with that chapter indefinitely. They are not subject to redistribution. That also applies to if you renew your membership fee and pay more than the allocated amount. Anything over goes to the chapter and stays with the chapter. So usage, the way you use funds, a type I chapter, which they have their own tax identification number, they file their own taxes and everything. They can request funds at any time. Use the form in the chapter handbook, please. A type U chapter, which most of the chapters are, basically submit receipts for expenses and then we reimburse. Treasurer will apply any funds spent on revenue sharing obligation first by default. So in other words, if any chapter that receives revenue sharing funds spends any money at all during the course of the year, we'll take that as allocated against your revenue sharing amount. So it's very easy to use up all of your revenue sharing funds in a year. Just do something. Revenue sharing funds not used at the end will be redistributed, and chapters can always petition the EAA board to restore lost funds. It's not necessarily always possible that you get your requests in by the end of the year. Personal circumstances, other circumstances, we can always petition the board to get to the funds. And I think that we already covered this particular stuff. Yeah, that's last year. Those are old slides. So, anyway, that's it for the treasurer.
Thank you.
Okay, I'm going to back up the slide because Will may want to talk about the point system and the memberships. But I'm going to hand the pointer to him and let him do it. Will, back up.
Okay, you won't be on that side.
Whatever you want.
Okay, I think I'd rather do this. Wasn't prepared for that. So in general, what's changed this year with membership has more to do with the distribution we talked about of printed version members versus the electronic version members, and the cost associated with membership, which Howard indicated had increased, is mainly due to postage, because postage has increased significantly. So I proposed to the board, haven't actually gotten a formal declaration yet, to increase the membership for non-US, and before Canada was kind of a different number than the rest of the world, but we're suggesting that now that the cost actually to Canada is the same as the rest of the world, that we should make that a fixed amount of probably $60 instead of, I think we have 48 and 50 something for the world, and so we just make that 60. And we should consider, based on negative numbers, that we probably should have an increase in the membership, which is probably not popular, but I mean, $25 for a year for a senior student member with electronic seems pretty damn low, actually. In today's world, I would think that we could stand to bump that up a bit and help out the organization. So that's my 2 cents. Now, the big difference that we have done, which are listed as bullets up here, has to do with non-paying versus paying members. Why would somebody come right? Let me explain, first of all, how that came about. There's a need in chapters to keep track of the people who come to the meetings who are not really members. You know, our charter is to educate the public about electric vehicles. The way to do that is to be as inclusive as we possibly can. So in the past, we have made lists of all the people who attend the meetings and try to email them. It's a whole lot easier if we just simply tell people, go register on the site. You don't have to pay. You can register and your name is there. And then if you register with, for instance, the Central Coast chapter, you will get a distribution of events that are coming up, meetings that are occurring, which can be done by any officer in the chapter. And so we started registering non-members. And the cool thing about that, from the standpoint of the EAA, is that every time a non-member logs on, he's prompted to upgrade his membership. And we haven't gotten a whole lot of those, but at least it's in their face. It's a short little deal, you know, a button, continue without and upgrade. And that's kind of a nice incentive to have people eventually become members later on. Okay, so the other side of that is that we want to make sure that people are coming to the site, using the site, and if they don't want to be members right away, we at least are hooked into those folks and they're hooked into us so that we can include them and educate, continue to educate them. So the distribution is such. The paid members are around 1,000 right now, which is about 1,000 less than its peak, which was about 2,000 at one time. And the non-members, if you just do a raw search for it, shows up as about 7,000. That number is probably actually around 5,000 who are active. The others are just, members who, the members at one time, and when you're not a member for 3 months, you automatically revert to a non-member status. You can, as I say, upgrade and become a member again, but that non-member status is very clear in the system. It doesn't allow you to see current events, except for the old issues. So you can go back a year and before and see issues if you're a non-member, but you can't see the current issues of current events. Yes?
What year was that? 2009.
That somebody asked me that about
2009.
yeah, I think it was about 2009. Something. Yeah. When we had, and it was right at a time when when electric vehicles were really starting to be produced. Production.
That was exactly a year before we had the police.
Yeah, exactly. So it was a time when people were really anxious and wanting something to happen. So. And now, I keep reminding folks that what's the purpose of the EAA? The purpose of the EAA is still to educate the public about electric vehicles. And believe me, based on the public I meet, we still need to do that. There's a lot of need. So go ahead. Okay, thank you. Is that this one? Yeah, it is. Okay, so this is where the chapters are. Actually, yeah, these are all chapters. Blue dots are all chapters. West Coast, the United States in general, and this is membership, the United States, the distribution, and world population. And not only we have a member in Russia, you'll notice, and one of the things, the significant things that happened last year is that we have a new chapter in Mexico. So that's kind of nice to have. Thanks to Sunday shifting, what we have, as Mark has pointed out to me several times, we have boots on the ground. So when we need to get people active in a particular area of the country, we just contact the chapter and it happens. And there are not too many organizations that can do that. And that's probably what the EAA is best at. So that's it. Thanks. Yes?
I just want to say this.
Let's hold the questions until afterwards, please. We're really on tight pitch here. We're going to put Chris back online. Chris, if you can dial in, I'm going to unmute the phone again. And let's hope this works. Here we go. Hey, Chris, can you hear us?
I am here. Do you all hear me?
Yes, go ahead, Chris. I've got you on the first slide, the focus slide.
Okay, great, thanks. Hi, everybody. I'm sorry to have to be just a little bit quick. I'll move along. If there are any questions, just Ron will flag me and I can stop. But so today we're going what we're going to, and Will and others mentioned before, is build the Electrical Association awareness. So our focus was to do a refresher of the website, get our social media active. We have pages, but we really haven't maintained them for a specific degree. To add some additional products to the online store and promote the store, to attract advertisers to current events for advertisers and have a good retention. Partnering with some EV publishers, we've got a similar Inside EV, the big choice and ones that are out there. Increasing for engagement, along with communication, And so that's the benefit. You have benefits that come with RFPD, but benefits like, you know, what else for example, if you just have to pay investors, if anything that can do like the other fees, just, you know, just when you do. Other questions, you know, go to the next slide. And I'll just stop over there. So, I'm going to go with the people I have. We've done some stuff, some advanced communication. It's a lot of stuff to study some kind of it and what we've been doing. So, when to the slide, the website, which is slide 5, we've now explain some of the limitations of the base there briefly, but one important thing is maybe we've got really make it on home change. I have doing it, especially in the modification. So you see that with the option and most have the highlight and the
Chris?
track of it. And then you go to the home, you see that part is listed there now with the discussion.
Hey, Chris,
So look at, yeah,
you gotta talk much slower, you're breaking up.
so, that,
I have something on that.
So I
It's only his audio we can hear.
Maybe you can move your microphone away from your mouth a little bit, not sure. Keep talking,
You talk with better?
a little bit, keep talking.
Okay. So I mentioned that we've done impressions this site. Putting in the park connect with top so that we all will see that. And these are distance to members. What gets due to is a further enhancement of the website. And this is done by your membership.com, touch on in a minute. That service is the host site and to maintain the membership database, etc. They're going to be refreshing it, that's for us upgrade. So that's a good thing for us. We are currently working to streamline the back end, well, the happen, the login, etc. So working on that. We have to clean up the foundation before we can really move forward on the front end. That's all everyone sees. And moving to part 1.3. I've got some additional costs put on there to clean up the page a little bit. We've added t-shirts, remember during NDEW, just a FYI, the shirts sold out 2 weeks. We had an organization did make a small profit. That was a big win. We've added a few more shirts, we streamlined the page, have more up there, more things. The good news that we've noticed is that someone buys like a shirt, they buy other products. And that's great news. We're also noticing that a big percentage are not members who are buying. So that becomes a target for us to get them to become members. So good news. And so a little later, we are actually seeing so we're seeing it to the sites, being able to email. So we're very good with it. It is like actually happening. Also looking at food programs, basically that means is that we carry a PA on our e-commerce buys it, it goes to the site, gets purchased, site, we get a percentage for it. And the plus never manufactured, that's what Amazon pays for. Why not, we're going to check that and that's good. So the cost, you get a percentage off the top. It's a good thing for the VA. But you're going to
Chris,
yeah.
what slide are you on? And also if you're on speakerphone, turn it off.
I'm not on speakerphone.
Okay, so what slide are you on?
27.
Okay, go ahead.
All right. I'm on the headset.
You're on a headset.
Take it off the headset.
There's some sort of weird feedback. Go ahead, you're breaking up on occasion. Keep going, keep talking slow.
I'll talk slow. All right, I'll reduce my range. Anyway. Excuse me, I'm in the parking lot. So this is your membership.com. This is what controls our website. This is what allows us to figure the data. Just want you guys to be aware of what this is. Just because this is really the bones of some of these in front of you and the things that are out there. Moving on to slide 28. probably something that you're all, I'm hoping that a lot of you are aware of these things that are coming forward. As a member, this is a big benefit to EA members. You still have questions?
Go ahead.
You get 5% off everything and quick out on their store as an EAA member. Now there's a code, so to see that code, you've got to be a member, but you need to log in to see it. That's a nice benefit. You also look at what electric motor work we've given us. 479 for 2 o'clock. That's appreciated too. Again, that's members. Now these folks on social media everywhere because we want people to sign up with us. Well, recently, we're practicing the pretty useful where members have not get 100% off auto insurance. Auto start rolling out too. So if you have a deal, or an EV, you do, you possibly might be a little bit on your auto insurance. So some of that we're just at two or important. Okay, so 29.
Well, maybe it is good.
And newsletter. I also using scan. We started to put in a one-page newsletter, not replacement species, species. In fact, it's a natural species. But that's what I just go to that. So in our database, members and not members, 80% people sending email. That is a huge number. 30% commenting in the email, and you come back to the website. It's like promote my tab. You see huge uptake on our Facebook Live, huge uptake website, and we see huge uptake in member block. So this is helpful in that it's really
He's basically saying web use is way up.
All those words got jumbled, Chris, I'm sorry. The discussion on this last slide.
And every slide.
what do you do?
Just keep going. You might want to repeat.
I'm gonna send an email. I'm gonna send an email.
Regular phone. Something that says.
Yeah.
Nothing
It's the
like
headset.
What part is not here?
Everybody's saying that they're convinced it's the headset you're using. I don't have a choice.
Oh, hold on. How's it?
Keep talking.
How's it? Better?
Better.
Yes,
Yes.
go ahead.
Okay, all right. So, okay, that's good. Then, I just was saying that those thousands of, yeah, 80% open it, which is a huge number. And a 30% provided. In the newsletter, we have to make that's from partners, industry news, survey, so lots of juicy information. And this is a compliment. It's not replacement. Both is available, and we can see both quick. So it is work. Well, it's up.
It doesn't matter.
Once they're up, but doesn't mean all the activity is up. We also see after long. Actually, new members something at the top. Outside. The top.
What page you on, Chris?
30.
Okay, keep going.
Social media. I really hope that you have a Facebook account and like this page. I don't mean like it as an emotional feeling. I mean like it. But when we started looking at the page, we had about 500. We have over 2,000. Activity is very, very strong. We make a post. We have tremendous activity. You're seeing activity that we do 5 times bigger than us. Yes. That means we have a very consistent audience. We receive stories organically, not paying to bring you guys. Even now becoming the news source. The news source. People want to learn about these. Our audience is not just those that want to build one. These are those that are interested in family. So that this is really good. We have these members Little contest up here, just to, help us.
What page you on?
The third one. Wait, can you hear me at all?
With difficulty, keep going. Speak slowly.
This is kind of being a burden. Facebook meme. This just talks about what we are doing to keep the interest and those engaged on the social site. We have visually. We have seen members sign up, but we don't have to direct back to our website, talk about the benefits that members get, and that's why you should also see members do not know. Okay, slide 32.
Thank you, we're there.
Okay. What we're doing to attract advertisers is we're offering more than just a page in DE. They now get social media placement, not an ad, but a call out to make it look like not an advertisement, so more like a partner. If they offer our members benefits, they will get more. So there's an incentive for them to come up with something that help our members, just like what eMotorworks did and Quick Charge Power. We have also gotten closer to the EV media I was talking about, and shortly you should see something really interesting come out where we have a nice call out for the EA on one of the leading EV publishing sites. Lastly, notice 33. I just want you all to be aware we are tracking all activities. So you'll see a graph on the right. That's from Google Analytics. That's what happens when EA newsletter goes out. That's really good. People are interested in what we have to say. We also track where they go on the site, so as you refresh it, this data will help. Slide 34. Just a quick snapshot for member login. When we started an aggressive push in December, logins went up. The number today for logins, I believe, is a record month. So again, it's positive. And I'll just finish with slide 35. Just moving forward and see what we're doing, a little bit more focused, and look for other ways to bring in revenue aggressively for the EA and additional benefits for members. Did I get cut off?
No. Somebody dropped off.
You're still on.
Yeah. You're still on, Chris.
Yeah, I'm here.
35.
Guys, I think that's the last one.
You are right. Okay, everybody. Thank you for listening in from afar. We're going to have our quick break, and then we're going to have our guest speaker, Victor Wolf from Mexico, come up and talk about wheel motors, and we'll switch to his presentation shortly. If you want to stick around and listen in, you can. We're going to webcast that also, right? Okay. Take a break, 5 minutes, we'll be back up. Thanks.
Oh, yeah. I actually, I bought the t-shirts and everything, but
That was awful.
Make it an out stop. And, you didn't get my example. Okay, and then there'll be one for Campbell. Okay. Wes, Jerry, here are your cards.
Oh, thank you.
So the way this works is that you fold these things inwards. You fold these things inward until you hear it snap off. So you just snap all the edges off and snap the cards apart. I'll just leave it in one piece so it's easier to deal with. So we can make more. I just wanted to give you guys a few to look at if you like them. If not, we can change.
Okay, cool.
Yeah, keep it going over. You don't want to make any. Okay, 5 minutes are up. Everybody can take their seat. Let's get going with our special presentation. I want to introduce the speaker, Victor Wolf. He's a long distance traveler. He comes from New Mexico. He's an ex-HP guy. He's worked at HP Loveland. And if you go to Amazon, go to the book section, you can find his book. I think it's in the second edition. It's called something like Machine Vibration. Circa year 2000. Pretty interesting stuff, especially for mechanical engineers. In any case, let me introduce Victor Wolf. Let's give him his attention. Thank you.
So I have my talking paper here. I'm from New Mexico, the frontier of New Mexico, so we think a little differently there. But let me tell you a little bit about what brought me here. I was a toolmaker before I became an engineer. My day job is I fix vibration problems on industrial equipment. I have a small company with 6 employees, and we travel quite a bit. I was a member of the EAA in New Mexico years ago. There's still a chapter in New Mexico. I tried to resurrect it, but I realized that if I organized the EAA, which is a volunteer group, I wouldn't have time to work on wheels. So I've changed my course and my priorities. I have converted 6 vehicles from gas to electric. This started as a college dream. And dreams stay dreams unless you have a trigger. The trigger was my second son got kicked off the school bus. So we had to find some alternate transportation for him. So we worked on electrifying the bicycle. And it developed into another prototype, and another prototype, and another prototype, and another prototype. So this is what we have presently. This is probably prototype number 8 or so. You see the wheel motor on the dynamometer. It's an 18-inch wheel, 26-inch outside diameter tire, standard car tire. It's a 3-piece wheel, and I'll show you the internal construction. This presentation, by the way, this presentation was done in Orlando, Florida last month for the Motors and Drives Conference. And I gave this presentation to a complete coach in Riverside, California last week. They're very interested in wheel motors for their electrified buses. But what I'm going to give the EAA here, since this is a privilege, we're going to see a little more than I presented to them. The internal construction of it and how it's actually put together. Let me proceed on here and back up a little bit. And we'll start from the wheel motor, and we'll get to the other slides. If we get to them. Here's the rotor. This is 32 magnets. We give it 3 inches long, 1/2 inch wide, 1/2 inch thick. It's an aluminum rotor. These holes here are for attaching it to the rims. There's a 3-piece wheel. If you're familiar with 3-piece wheels, 2 rims and a center plate. The center plate I've fabricated and placed magnets in there. The reason for that is so that we can change the tire on the road or without disassembling the wheel off the vehicle. That was one input from one observer in my shop. It's an aluminum rotor. It sounds like that's not a good idea because of eddy current loss. So the second prototype was a composite, but then we came back to aluminum. It may end up being titanium in the future. Here's the rotor mounted in the wheel. There's the bolts. There's 40 bolts around here. And then there's a rim and the tire. You can see it's come off the test stand, so there's a little grease filled around there. These slots here are for a pin brake. That is just like on an automatic transmission vehicle when you can engage a pin to keep it from rolling downhill. The previous prototype had a band brake in there. I removed the band brake because it was not very effective, and it just generated heat there. So here's the stator. There's 24 stator poles. Here's the Hall sensors. There are 2 Hall sensors on each 1/2 inch board here. And that I got actually from a Honeywell application note. If you take 2 Hall sensors and parallel them, if one fails, the other one will continue to sense the magnet position. And what I found is I started off with a single Hall sensor and I had a Hall sensor failure. Later I had another Hall sensor failure. So I decided to double up on the Hall sensors, which is a good idea, and parallel them. What happens is with 2 Hall sensors parallel together in the Bohr fashion, it actually senses the timing position of the magnet flux more consistently. And if you look up here, you'll see another set of Hall sensors up here. So there's a redundant set of Hall sensors. There's actually 4 sets of Hall sensors in this motor because I realized that if a Hall sensor fails, you need to disassemble the motor to repair the Hall sensors. And it's easy in code to just, if a Hall sensor here fails, the other one will just continue to sense seamlessly, and the operator would not know. And if 2 Hall sensors on the same board fail, we just simply disconnect the connector on the outside, reconnect the other set of Hall sensors on the road, keep going. So this is prior to impregnation. This is after impregnation. The entire stator, both stators, there's two stators, are vacuum vacuum impregnated with bag vacuum system. There's a covered plastic bag, warm up some epoxy resin, pull it back and suck it in. Everything's completely coated. The reason for that being is that the motor can run underwater, not a problem. And here you can see the Hall sensors have moved. They were out here on this post and moved them right in the middle. I didn't think that would work because that's a very strong electromagnetic pulsed field right there between two stators. But actually, it worked better because out here, the Hall sensors are on the fringe area of the magnet. But in the center here, actually counterboard with a half-inch drill, a half-inch needle, and set the board right in there. It actually senses the position of the magnet. So here you see the axle. There's a tapered rubber bearing there. These two holes right here are for releasing the bearings. The reason for the hole is we have to pass wires through the center of the axle. You'll see the reason for that shortly. Here's the power wiring, and then there's thermistors embedded in here, one on one side, one on the other side, and temperature sensors connected somewhere here. But there's a Hall sensor connector, another Hall sensor connector, and there's a temperature sensor and power wiring. This is a fixture to remove the.
Hey, so can they help on like get a hold of you? What's the call Monday?
Okay, I'll just be talking. When the air gap is 125 mils, it took a little while to come to that exact air gap. If a smaller air gap you think would be more efficient, and it is, but then we run into cogging torque, which is counterproductive to torque production. Larger air gap with more higher speeds. Anyway, 125,000 air gap seemed to be ideal for this particular motor. But when we lower the stator to the magnets, there's 500 pounds of force. So we need to remove that. And this fixture is for, well, it's basically just like a big gear puller, but it's custom made. It pushes on the rim. We bolt up to the stator and we just rotate these thumb knobs here. And we can raise it in a controlled manner. We had to get to this point because we were disassembling and reassembling in an uncontrolled manner initially. So here's another picture of the with the stator removed. Of course, you see the flux density, the open circuit flux density of the magnets. Every time I ran this motor and I disassembled it, I would measure the open circuit flux density to see if I'm demagnetizing the magnets. And it survived, nothing has changed. Which tells me I probably have oversized the magnets. They probably could be smaller. So these bolts here are accessible from the outside. There's the air. That's to unbolt the wheel and the tire assembly from the rotor, leaving the stators in place. So the stators will be bolted up to the axle, and you can pull the wheel and tire off, take it to the tire shop, Discount Tire, and they will remove the tire for you, put on a new tire, and you can bolt it back up without disassembling any part of the motor itself. Here's the adapter plate, which needs to be fabricated and built and have to mount on the vehicle chassis. Here's the connectors, power connector. Here's a Hall sensor connector and connector sensor connectors. These are the bolts that hold up the stator, the stainless steel. So everything has to be non-magnetic on the outside. Otherwise, it will pick up all the iron off the roadway. There's a very small gap there. Here's the motor mount on dynamometer. It's a modified dynamometer. This is a torque plate. This green thing out here is a urethane seal. There's a small gap there. It's a clearance seal, so that nothing can be going into there, that would be magnetic. These two wires, this is a temperature sensor wire, the orange one, this one is a power wire. It's a number 12 gauge stranded wire. There's the axle with a lock nut on there. The reason for the torque plate was this motor produces so much torque that we wore out keys. In fact, we wore out several sets of keys. I started off with round keys, we wore those out quickly, and I went to square keys, and I went to longer square keys, and double square keys, and it still wore out the keys, and the keyways, and the axle is stainless steel, but it wore out the keyways or wobbled it side to side, so I had to add this torque plate, and that's a common problem with all dual axle gap motors. They produce a lot of torque. So this one works. It has not been on a vehicle yet, but it will be soon. A prior prototype was not on a vehicle, which I'll show you. Here's another picture of the wheel motor on the dynamometer, chassis dynamometer. Here's the two power sections, and there's the digital logic section. Now, the two power sections are in separate boxes. That had to happen after a year of noisy operation and misfiring, and we have run this motor at 400 volts at full torque, and it just slammed back and forth because of the noise generated within the controller. The digital section used to be in the same box with the two power sections, which was my ignorance. I wish I had Ron's consultation, which is why I went down this path. But what eventually had to happen was the two power sections had to be separated, and the digital logic section had to be separated. Realize there's two motors here. There's a stator on one side and a stator on the other side. So there's two separate motors with two separate controllers for redundancy. So if one motor has a failure of some sort, shorted wire, or if the power section fails, you can still get home on half power on the side. So I built this redundancy into it intentionally. Here's just a picture of how it's attached to the vehicle. So there's the stainless steel plate. That would be a drilling cap to mount to swinging arm or chassis. So if you think about this, this can become a hybrid. You can leave your internal combustion engine and transmission up front, add wheel motors to the back, and some batteries, leave a fuel tank in there, and if gas is available, you can use gas. If it's not, you can run on electricity. And if gas is available, the motor will generate. It's an excellent generator. Here's what we don't want to happen. This is an Auburn Scientific controller with some of you may remember. This one actually failed this way in a previous conversion I had. And they fail short circuit. So you get full battery current to your motor. And this was on a Renault that I had converted. It was on up against a 4-inch curve in my shop, and the door was open in the shop. And my son saw it smoke a little bit. I was about to leave, and I energized it. He saw a little puff of smoke. And I was in control. I said, well, let me back it up to the shop, and you stand outside and watch what happens. So I turned it on again, and as soon as I turned it on, it went to full power. Fortunately, it was in reverse. Its wheel tires went over the 4-inch curve, slammed into the door, bent the frame of the door, and rearranged my shop wall. So we all know the solution to that is you have a controller that has two Zonta relays. One you turn on, and the other one the controller controls. So if you have an overcurrent condition, it will shut that off. Well, a brushless motor does not need that, because if a brushless motor does not get a Hall sensor switch, it just stops. It won't move. So this is inherently fail-safe. That is, a brushless motor is inherently fail-safe over a series line motor. A series mount motor will to this full power, there's no control in it. You don't want that to happen when you're in traffic between two vehicles. Okay, so this is our power section. But this is the digital logic section. There's two digital logic sections. There's one board on top of another. This is a daughter board. It is an add-on prototype, which will be changed. There's two LCD displays. We have an on-off switch for left side, right side, one speed pot, and of course the clockwise, counterclockwise position. So everything can be controlled from the box and driver position. It won't look like that in the vehicle. Nobody's going to buy my wheel and sit it in their living room and stare at it. It has to be connected to a vehicle. So I need a strategic partner. A strategic partner will design and display for the driver. That will be their contribution to the unique stamp. This is just a prototype. Here's the power section. Here's the zone 50 contactors. We're going to add another one. Here's the power going out to the one wheel or one side, power going out to the other side. Here's the DC input in the batteries. And there's the gate driver board, the IGBT is below that. It sits on a 3 4-inch thick aluminum plate. If you look at these two tubes here, there's a water cooling. All the rest of these connectors can all be integrated into one single connector in time. Again, this is a prototype. And you notice the copper shielding around some of these wires that was necessary. We found out. Oh, and the capacitors. There's the capacitors, but probably undersized. We're looking at the thin film capacitors presently rather than the big electrolytics. The thin film is probably just as big. This is the weak part of the electric vehicle, is a controller. I always recognize it with. 5 years ago, I didn't think I could build a controller. Fortunately, my stupidity did not create an obstacle. I continued moving on. I have an electrical engineer who's been consulting with me and has been a tremendous assistance. I'm a mechanical guy. I'm not an electrical guy. And to build a wheel motor, or any motor, you really need to build a controller that goes along with it. So I went down that path. And even at my age, I had to learn C programming. Now, I dropped out of an assembly class 4 years ago when I was in college. But you can still learn. You should do that. So nothing here is proprietary. The dual axle gap motor is nothing new, which I'll show you in just a minute. Controllers, pulse width modulated controllers are not unique. Probably the only thing that's intellectual property here is the code. And the code we have designed to have a startup sequence where prior to energizing the 400 volt to this contactor, we have a set of relays that measure all 3 phases on both sides and verify that we have no shorts and we have no openings before it turns that contactor on. It does that every single time. It takes about 3 seconds. Okay, here's my wall of shame. You see all these IGBTs that are exploding. And they fail typically by blowing off all the bond wires. There's a few other components over here that have failed. But the IGBTs are rather sensitive to over voltage. They're 600 volt IGBT modules run derated to 400 volts. Because of pulse width modulating, you can have spikes that will go to 610 volts, and then they don't like that. And also found out that you can't put 50 foot of wire from the battery pack over to the controller. The inductance in that length of wire is enough to pop these also. So most of these failed in the prototyping process where we're trying to work out the timing. And that's the unique part of this, is getting the timing right. Because when timing is not right, you'll have phases working against each other and motor working against one motor working against the other motor. So here's the IGBTs. They blow off the bond wires. So 3 of these are power switches, the other 3 are freewheeling diodes. The weakness in these are really the freewheeling diodes in IGBT, intelligent modules. The freewheeling diodes are kind of undersized. These are PowerX modules, and I got the scoop from PowerX engineers that they really are undersized rather than the switches themselves. So I found out what the weak parts are here. Real close-up view of some of those. It's hard to tell what went first, but I suspect it was the freewheeling diodes. When they fail, then the switches go to. Here's a tabletop demo that we started off with. So rotor is in the inside, and you see the coils. And the ratio here is six wound coils to 8 magnets. And that was discovered through several prototypes. But I really should have talked to a colleague of mine in San Diego who was working on a motor also at the same time. And he came up with the same ratio, so that seems to be the magic number, 6 to 8 ratio. It works better that way. Other ratios, we have torque pulsations, and it doesn't produce as much power. So this was a prototype. This back here is just a motor that we use as a generator, and I'll be short out the wires and put a resistor on there for the testing. This one still works, by the way. My colleague has it for testing purposes. So we use this to select the best pulley slot ratio and validate for zoning equations. Here's a full-size prototype. This one is an earlier prototype with a motorcycle wheel on it. It's all aluminum. You know, Harley-Davidson makes solid aluminum wheels for the rear, and that was easy to just machine out and put magnets in here. When this was first produced, it works fine. It still works fine. But a couple of engineers from Los Alamos were in my shop, and they said that's going to have a lot of ignorant processes. Well, from what I know about electricity, I agree. So the next prototype was a composite, and this is a composite prototype. And there's the magnets. They're embedded in the composite material. And with this prototype, we also went to a removable wheel. That is, this composite is molded separately, and we have an external wheel which has been modified, and we can mold it up to, so I can remove the bolts through that wheel off, because I realized that being able to change on the road was an important characteristic. But the composite was hard to produce. This is a composite on the dynamometer for testing. This went on a Ford Ranger at 144 volts. It moved the Ranger. The Ranger weighed 5,000 pounds. It was all the lead-acid batteries. They moved down the road, not very aggressively, but that validated this torque reduction for this motor. This motor actually had less turns. It had 47 turns per coil. We're now at 57 turns per coil. And also we had more teeth, so the timing was not right. You know, it's important for dual axle motor for those stators to be registered properly. They can't be offset. They can't be offsetting like this going down the road with torque reduction in both directions. So it moved it, but it had some defects while it moved it. So this prototype sits in our shop, still works, but we've gone beyond the design. Here's a problem with the composite: is mixing the epoxies. You have to have mold to do that. So here's the bottom mold. These guys are mixing the resin, poured in. We have to have preforms because there's so much epoxy here and so much surface area, you can't take it apart. It's all glued together. So we have to have preforms. So there's a preform on the side here, and there's a preform on here. This is the previous ring we had in here for engaging with the epoxy. So epoxy was put in here. This ring here, this aluminum cylinder, was to control the bearing alignment on both sides. And with this epoxy, not only was it labor intensive, but I couldn't control the bearing alignment. And that's important because at a 3-inch diameter bearing, once you get to about the diameter, we have wheel weld. So we abandoned this prototyping process and went back to doing the wheel. And here's the top part of the mold. You can see we have to pour it in. And we disassemble it all. And we have to cure it. So it took really too long. It's much quicker to have a rotor plate machine and then just assemble it. Okay, let me go back to the presentation. So this is something that others have not seen, and I wanted to share it with you. So dual axial gap motor is not a new idea. It's promoted by all the motor design books. We see about 6 or 7 of them, but 3 are prominent. Professor Hanselman, Hendershot, and Professor Garris in South Africa. They all promote dual axle gap as the ideal design for traction vehicle applications. So it's not new. What I did is I'm just a machinist. So I took their idea and formed it in metal. So there's a dual axle gap machine at the Henry Ford Museum in Dearborn, Michigan. It's not a magnetic design. It has round rotors. There's a rotor in the center, and these are two stators on the side. This is about 100 years old, so it's not a new idea at all. This over here to the right is a propulsion motor from the 70s. It comes right out of Professor Gearhouse's book. That motor produces 1,000 horsepower. It's two stages. That is, there's one stage and another stage, and that's the beauty about a dual axle gap motor. You can just add stages and produce more power. Some specs on that motor is it produces 2,700 newton meters of stall torque, 290 amps, 735 volts. It's a 3-foot diameter. It weighs 340 kilograms, or about 750 pounds. And it moves submarines. It's low speed, high torque application. Same thing as vehicle traction applications. That's power density of about 2.2 kilowatts per kilogram. So here's some dual axle gap designs. This is right out of Professor Gearhouse's book. We have the rotor in the center and two stators, one on each side. And this is a view of the stator lines with the magnet over there. This is from Hanselman's book. Again, we have a rotor inside and then two stators, one on each side. And this is from Hendershot's book. We have a magnet and then rotors, and they're elliptical style, round coils. They're called the salient rotor. And the beauty of that is you can round each one of these individually on a coil winding machine for high-speed manufacturing. That's what I focused on in designing this wheel motor. Standard motors, induction motors, you have to wind the wire in the slot. Actually, you have to put insulation within the slot, wind the wire, go around, put it in another slot, go around, put it in another slot. And all the phases are intertwined in each slot. And to repair that, if you have a short, we have a lot of copper close to a lot of iron. And if we have a short, then all of that wire has to be stripped out or burned out and rewound. But the benefit of this design is if we have a short in one, we can identify the phase that's there and find the particular coil, just unbolt that coil, flip the wires, put in another coil, resolder it, bolt it up, and you don't have to lose all that copper. Okay, here's a little bit about wheel history. It was a wonderful invention. I think we're stuck with it. And if you roll around rocks, building a rock wall, I think you see that some of the ancient guys realized that this thing was really a lot easier to go around. So, Potter's wheel has been used since about 6000 BC, and it's not hard to imagine a Potter's wheel. It was worked by foot just to make clay pots, to store water and store grain and keep rodents away from it. A cartwheel was unearthed in Eastern Europe, somewhere near the Romania, about 3,500 years ago. The wood wheel was preserved in a bar. So it's a little bit, we don't know who invented the wheel, but I think we all like it now, don't we? Probably the need to move heavy dogs over rough terrain was the incentive to do that. Now there's many variations there. We have road foot, we have fans, pumps, electric motors, generators, machine tools, rolls, turret, bearings, couplings, pillars, shafts, gears. All these are variations on the wheel. Now conventional wheel or conventional motor is long and cylinder. I think it was designed that way by default for some reason. We had higher speed applications initially, and we've kind of been stuck with that for a long time. And this wheel produces high speed, but less torque. And to get more torque, of course, we've added gears to that, we've added pulleys to that. And it has to be coupled to the machine is going to drive. So we have additional components there. We have additional shaft, additional bearings, and additional coupling. Well, it makes sense. Why don't we just put that wheel with that motor right inside the driven component. And this shows the tire on the outside of the road, and it shows the tire coupled to the rotor with stayers on each side. So it eliminates a number of drive components. Actually, I think the bigger application for this is in the industrial world, to integrate a motor within a fan, and integrate a motor within a compressor, and integrate a motor within a pump, and it's being done in some small applications. So it eliminates drive components, picks up less space. It's in a hub delivery machine, and actually delivers more torque because it's larger diameter. We have larger radius. So here's the present cross-section of our prototype. Everything in green rotates, and everything in red is stationary. So we have a three-piece wheel, two limbs, they're bolted together to the rotor, and in the rotor are magnets. They come down to roller bearings, conventional, and wheel. Here's the axle. There's a hollow axle so that we'll bolt it up with this adapter plate to stationary part of the vehicle, which is a swing arm suspension. And then the wires to these coils over here, we can connect right up, but the wires to the other side have to come through the axle and then connect it up on this side. So we're using both sides of the magnet. This air gap is about 125 pounds in an inch. That's the benefit is there's no rotor on it. We're just using the both sides of the magnet at the same time. There's two stator windings, so there's more copper. Now we have two controllers for redundancy. We get better heat removal because the heat is generated right here at the stator, and it has a real short path through this steel flux ring to the outside through this half-inch beam of plate, and we get free cooling with the relative ring over that wheel. The air gap is adjustable for different applications, for more speed or more torque, and by placing shim right here between this stator plate and this bearing block, we can place a small shim in there and adjust the air gap. Not on the fly, but disassemble it, add some shims. Each coil is individually wound for high-speed manufacturing, and it's a modular design that if I can take these coils and move them out to a larger band, put more coils in there, change the number of turns, and we can design a motor for a specific application of the voltage that's available, the torque that's required, and speed that's desired. Aircraft manufacturers are very interested in wheel motors for nose wheel applications because then they can remove the tugs from the gates. They can just power up that wheel motor in the front nose wheels or in the main wheels and they can back away the gate and taxi through when we run without burning out of fuel. Airbus already has a design. Boeing has been interested in it. Talked to them a few times, but I can't produce the motor powerful enough to move 100,000 pounds yet on the nose wheel. Here's the preliminary specifications of our wheel motor. Configurations of dual axle gap brushless machine. Maximum voltage is 600, which I rated at 400 volts for the minimum switches. The peak torque is actually calculated to be 2,000 foot-pounds by the motor equations. I have conservatively rated at 800 foot-pounds to 300 amps. Continuous torque 200 foot-pounds to 100 amps. Maximum speed 125 miles an hour, and I have had up to 150 miles an hour on the dynamometer unloaded. Once I lower it down onto the rotors, I can do 125 miles an hour. Some people use that speed, but I did have a company in Japan wanting to know if I can make 6-wheel motors for their vehicle, or they want to go 200 miles an hour. Excuse myself in that project. I don't think that's my target market. Oops, back up. They're neodymium iron boron rare earth magnets, and one of the problems with this motor, I'll tell you up front, is the Chinese control 95% of the rare earth magnets worldwide. We were painfully aware of that in 2010 when they cut off the Japanese from supplying rare earth magnets to them. So the Japanese have reconfigured their supply chain, and also the Department of Defense here has recognized that this is a strategic resource. They've opened up Mountain Pass mining for rare earth metals in California. The Canadians have opened up a mining operation, and so have the Australians. But my motor can be redesigned for ceramic magnets. It would just be a little bit more magnet material, but I left that open as a possibility for the future. And I realize that that's going to be a limitation is the supply of new magnets from China. The wheel, total weight is 157 pounds per tire. A standard 18-inch wheel tire weighs 50 pounds. So I've added about 107 pounds of weight with copper and iron and magnets. Not a lot of weight, but there's a little bit here. 18-inch wheel, 26-inch tire that are presently designed, but it can be modified. Then the paper roller, two separate IGBT controllers, a pulse width modulator, one for the stator. We use sine cell space vector modulation with phase advance. It's kind of state of the art for inverter controllers. Mounted with a stainless steel adapter plate. So that's the only thing you need to machine for each particular vehicle application is that stainless steel stator plate has to be built and have to mount on your chassis. The cores are sintered iron powder metal that are manufactured in Dallas. The cores have a plastic sleeve that slips over them for lining wire. I got away from paper because I had enough shorts with paper insulation, so I just had some sleeves made just about 30 mils thick to slip over the iron and be lined with wire directly with the sleeves. So there's really not a good opportunity, even in the future, for copper to be shorted iron. And costs here, I've done two costings. I was manufacturing for Hewlett Packard, so I knew how to do costing for final product. And the costings are between $4,500 to $9,000 depending on quantity. That comes with two IGBT controllers and a digital logic section too. So you really have to design a controller to match a motor, and that's what I've done from the beginning. And it does do electronic generation. In fact, it's an excellent generator. When I de-energize it on the dynamometer and I let it coast down, it really goes over 700 volts and it has killed some of the IGBT. Okay, so here's the benefit of a brushless motor. We produce the maximum torque at 0 speed where we need it. This is the profile, and this was displayed to me years ago by a Hewlett Packard engineer, electrical engineer, told me that electric motor is ideal for traction applications. And I think I'm speaking to the choir here. So why wheel motors? Well, less parts. It actually has potential to be lower cost to manufacture than the other kind of motor. If you purchase an induction motor, then you probably need to have a gearbox with it. That's Tesla has discovered. It has the potential to be more reliable. Maximum torque is 0 speed, reliable energy source, which is electricity, that operates without oxygen underwater and in a vacuum. All of the rovers that we placed on the Moon and Mars have wheel motors on. Consumes almost no energy when it's stopped. There's a little bit of, I think 200 milliamps going to the controller to keep it alive. Torque production is close to the point of use, which is just a good engineering principle. Frees up space in the vehicle for other purposes. And one wheel vehicle is possible. You've all seen this. Now, I don't think I want to be on that vehicle. And this is his daughter, of course, just for full opportunity. But the designer has ridden this vehicle, and it has it's a dual axle gap design. That's the only way you can do this. And these are stators, so that does not rotate. The tire rotates on the outside, but the stator is not. So that would be a strange thing for consumers to accept in the future. But we're all about strange between, aren't we? You know, people like to see that wheel turning and making some motion, but the stator does not rotate. The only thing that's going to rotate is the small piece of aluminum wheel that's just in the tire. But you know, this looks like something that's risky to buy. Look at your local radio and see what kind of speed some of these young men get on. So I think it might just take a couple of generations to move over and be comfortable with this. Okay, here's some of the counter arguments for wheel motors. One is range, and I'm not going to get into that. Tips need to be managed. Unsprung weight, however, that always comes up as a counter argument. You want unspun weight when you're motocross racing on a motorcycle because you want that wheel to spring and get back in contact with the road. So if you're on a unimproved surface or a rough surface and you want to make quick turns, well, then unspun weight is a significant factor. But if you're just going straight and level down a smooth road surface, I think it's actually beneficial to have more weight rotating because it gives you gyroscopic stability. So better for stability, I think more weight on the wheel. Now, remember, my wheel, as presently designed, adds about 100 pounds to the total wheel, but the rotor itself is only about 7 pounds more than the standard wheel. So the other issue with the wheel motor is the added rotational inertia. So with the magnets on the rotor, I add 7 pounds to the rotor. And that rotor has to be accelerated every time we come to a stop and has to be decelerated. So that takes just a little bit more energy than a rotor that weighs less. But I think that's insignificant because look at some of the oversized tires that people put on wheels and they keep on riding with it. So. Okay, watch out. Well, high energy magnets have been available since 1985. Prior to 1935, we did not have any magnets. We magnetized iron. So when Porsche built his wheel motors in 1900, we did not have the benefit of any kind of permanent magnets except for the magnetized iron, which was quite weak. Ceramic magnets came along in 1935, and Nikos and Samara Cobalts in the 1950s, and Mitsubishi and General Motors presented neodymium rare earth magnets in 1985. And they're the choice today. We have reliable pulse width modulated controllers. We have high power semiconductor switches. Power is working on 2,400 volts switches and 1,000 amps, not in the same package. But we didn't have those 20 years ago. Battery chemistry continues to improve every month. Hydrocarbon fuel costs are increasing, supply uncertain. Internal combustion engines are complex, costly, and community. Zero emission vehicles are being mandated by some local governments. I believe the city of Los Angeles is now diesel free. And Paris is considering by 2015 outlawing diesel vehicles within their city. So environmental regulations won't just prevail. What are the problems? Well, one is rare earth acid, which I've elaborated to. It produces a lot of torque. I think I saw that with torque plate. Control of reliability, I knew right from the beginning was going to be a problem. And we're working on hardening our controller. So it's not quite ready for commercial application yet. The capacitors are the weak points and trigger wires. So we're working on improving those and hardening that controller so it will survive. Whatever it is we're doing. So by the way, all the failures I've had on this wheel motor have all been electronic. All the abuse that we've done in prototyping, the wheel itself and the motor has survived. All the failures have been controlled. Tire replacement, I think I solved that problem. Pump sensor failures, I've solved with redundancy. Disassembly in the field, I solved with this fixture to remove it, which can be packaged for a tool person to run and disassemble the motor in the field if necessary. The handling of high energy magnets is a problem in production. This has been one of the resistances to building permanent magnet motors because of course, the high energy magnets will slam into each other, they'll pinch fingers, they'll crack, and the particles flying. The way I have solved that is with this rotor plate is I intend to purchase the magnets in green state or unmagnetized, properly illuminated, machine out this aluminum plate or titanium plate, put the magnets in there, retain them temporarily with some super glue, and then cover both sides with 2 layers of fiberglass to retain the magnets, and then it's going to be captured that way. You're never going to magnetize it with a magnetizing fixture, which is going to cost a lot of money. But with chargers and capacitors, you only need about a half a second to energize the magnets, and then reverse the polarity, index it one magnet over, energize the other. So we'll energize the magnets and the captors and send those data. So that's my presentation. Thank you for your attendance.
Yeah, your DC coming in, is it DC coming out as well?
It's pulse width
Your
modulated.
controller?
Pulse width modulated.
Pulse width
Yeah,
modulated.
it's actually the sinusoidal pulse width modulated.
So it works like a series round DC motor, pulse width modulated? Is that how it works?
It works exactly like a variable speed drive on induction motor application, where it generates a sine wave at the frequency you want to, controlled by the Hall switch. Yes, sir.
A while back, we had a presentation on what we call variable reluctance motor that doesn't use it back to all. Are you familiar with that?
I am, they know a lot of current. The vectors have a reluctance motor, and some other applications where they're cheap to make, they don't use magnets, but the drawback is they need to run at high speed, they draw a lot of current. Any other questions? Well, thank you.
Thanks, everybody. That pretty much wraps it up for today. I encourage you to go to facebook.com/Electric Auto Association. No spaces, no dots, all spelled out, don't misspell it. That's where we're at. Appreciate your attendance. Thanks, everybody.
You promise?
Beverly, come on up. He has an announcement to make.
Hi, I'm Central Coast Chapter. I just wanted to encourage all of us. I'm glad to see that Chris is working on this marketing angle. And I would like to encourage all of us to brainstorm what we could offer excuse me, to our members for value added for the membership in order to, that's speaking to the drop off in membership. It seems like a lot of people get information from us to get their electric vehicle, and then once they get it, they take off. So I think if we had it to be kind of like a AAA membership, the road membership, where you have some value added, where you get discounts. And I encourage us all to brainstorm that in our regions to, and I don't know if we would, how we would coordinate it, if we would work with Chris on that or what, but just let's be thinking about that to move our club into a new phase of what would be something that people would want to become members for.
Cool. Thanks, Beverly. Jerry.
Rob, I said, well, I've got so many people here, based on how it's budgeted stuff, I just kind of want to see a show of hands. How many people on a daily basis go to the website inside the news and put that in the news feed? So it's about, and how many people get the hard copy of content? Is that what you do?
More.
And if you got it electronic,